Welcome, everyone. This is an exciting time for AI. We've been doing this for over a decade. And, in the beginning, when we did open source algorithms, it was like implementing counts, histograms on a Hadoop system, right? With instead of doing stuff on disk, we went to memory. And that was already fast. And then multiple machines. And then, wow, you can do algorithms. And we implemented gradient boosting, deep learning, linear models, and those are widely used by many industries, as you know. Oh. There you go. Some martial arts training helped. Okay. But then we did driverless AI, and that was 5 or 6 years of really good work, and Achraf was one of the main contributors for that project. And we have learned that, it's not just about the algorithm, it's also about the framework around, right? You have to give these pieces of logic a place to live. It's like you have to put all the pieces together. You have to import the data, you have to manage the workflow, you have to build the hundreds of models, figure out which ones work, combine them together. And at the end, you get one final model, but it's really 3% more accurate than if you had it, just the original model. Even if you do hyperparameter tuning, that's not enough. You have to ensemble, you have to do proper cross-validation, a lot of techniques that still are not known to most people. When people think about AI, it's not just a deep learning model, right? It really has to be good statistics on good data with knowing what does this feature mean. And if you don't know what it means, then AutoML can squeeze out the information. But if you know what it means as a human, you can still add extra value. So now the great promise is that these LLMs, because they have seen the whole internet and all the data science textbooks and discussions online, they can now think, maybe I can extract a table from a SQL database, and maybe I can make some good features, and I can give the model what it needs. But it's still humans in the end, right? You're not going to have just the agent do it, but the agent can think. It can make up plausible stuff. And then you throw it into driverless as a signal detector, and driverless will say, yeah, this table that you extracted here made some good predictions. And then the human has to look at it and say, well, I can't use that feature because it's the future. It gives away the answer. So, okay, try it again. But at least it does the boring stuff, right? The extraction, the cross-validation, the fitting, the testing, all that stuff is automated, even the report generation. And now with these LLMs, you can do a lot. But, if you can read this slide, I'm not sure it's big enough. I have a 1 gallon jug and another 1 gallon jug. I want to measure exactly 1 gallon. So what do? You take one and you fill it up, right? But no, the LLM, and this is Haiku from Anthropic, the first one from March. But it says, okay, fill one, put it to the other, then, sorry, is this dongle not working? Yeah. It says fill one jug, pour the water to the other jug, and then go back, and then you have 1 gallon. So it learned from the internet that these jug problems are supposed to go back and forth. So it just tells you to do that. And only the smart models actually know not to do that. So this is the bad model, let's say. And if you take the latest version of Haiku and run it again, it might get it right. So there's not infinite wisdom in these models yet, but some of them are pretty good. So you need to know which one is good, which one isn't, right? That's why we have pretty much support for every single model on the planet, whether that's in any of the 3 clouds, any of the large vendors. Claude, Anthropic is definitely a smart one. OpenAI is still pretty good. Then there's Mistral, open source ones. Google has some open source ones. And we like, of course, our own, Danube and Mississippi, because they're small and useful, especially if you fine-tune them for your task. You could, for example, take 1,000 things you have, ask questions from GPT-4, and then give good answers and all that, and then you fine-tune a little model, and suddenly you have the knowledge from the large model in that little model for this one use case with 1,000 questions. And then you continue to iterate, right? And you want to have that done by humans, and then agents will eventually take over, and then you have one button that just does this. And then from now on, you have a little knowledge distiller. And you can do a lot, right? You can take audio files. I uploaded an audio file of a presentation, and I said, who were the speakers? And it already, the system that we have, h2oGPTe, already has support for audio, PowerPoint, Excel, whatever you name it. Every file type, Word files, stuff from the internet, 50 different types of files are supported. And for the audio files, you have the left and the right channel. Both are individually diarized into who are the speakers. All that stuff is extra, right? You go to LangChain or somewhere, or to some online repository with agents from Microsoft, for example. That's a good starting point if you want to do it yourself. But that's not everything. You need more, right? You need all these little things, the ingestion, the security, and then the logic to just do this for you. And if you want to do this from a script, then you have a REST API or an RPC API. We have both. You can connect to it asynchronously or synchronously, Python, JavaScript, Java, any language you want. You can programmatically drive this platform. You can also say, make me a picture. I said, hey, make me a picture of a unicorn flying on top of the NASDAQ logo. The Wi-Fi is a bit slow. Okay, I said, fine, that's nice, but I really want to have H2O on it. So it added H2O, but it didn't really spell NASDAQ right. So I said, okay, write NASDAQ correctly, okay? So here, finally, we got that done. So that worked. Or I can ask for the latest news, make a report. All that stuff is now taken care of, right? And this is the news from today. And I wanted to show you real quick. The first one was using Sonnet. Here you can see Sonnet 3.5. It cost 40 cents to make this report. And it figured out that Bitcoin had a new high. Nvidia stock is a little bit up. And then earlier it said it was down. Now it's a little bit up. And there was a new Bitcoin, options news that came out today in the NASDAQ. That's all real time. And then it shows the plots that I asked for. And that's all good, right? And now you say, well, I have no internet. I need to do this in the data center, in the basement. Can Llama do it? And this was the second call I did with Llama here. This would run on-prem in your basement with no internet. And it obviously then needs the internet still to get the news. But you would have your secure API for your tool. So how do you get that tool in? Well, it's one of these many tools on the right that you see here. And we will give you custom tools for agents. And the agent will also create their own tools, right? You can say, write a Python script that has this API and stick it somewhere. And then the agent can make its own tools and start using them and so on. It really will become really crazy, actually. But in the meantime, we will make those tools, and you will make the tools, and we'll put them in carefully, just like custom recipes we used to do for Driverless AI. And what I wanted to say is that even Llama can do a good job. It writes Python code, executes it, looks at it with the eyes of a Pixtral or of another vision model like Mississippi, and says, yes, it's all good. And it creates the files, the charts, the PDF report, how it made it. There's literally Python code that you get at the end, right? It's not just hidden somewhere in like a GPT-01, thinking, reasoning step, but this is, you can actually see everything. And last but not least, of course, Driverless AI. You can just say, hey, train a model on this data set, and then boom, it does it. And of course, there are some API keys that have to be configured. And in the background, you have to run Driverless AI somewhere in the cluster. But all of this is scalable, and it works. It's actual Driverless AI and actual results coming back. So this is quite helpful, right? It took like 20 seconds to run all this, and it gives you some ideas. And this is not just, hearsay or hallucination or some sklearn, but it's literally calling our existing tool that we know works. And there's tons of stuff, custom prompt templates. You can change how it speaks. You can say what the meaning is, the system prompts. You can configure stuff. You can change languages. You can have document AI. So if I do like a driver license, not driverless, but driver license, I should be able to find a file that I uploaded a while ago. Here we go. And that driver license file, I can say, okay, it's a document, right? It could be multiple pages or just one. And as soon as that's done, I can create that into a JSON. I can just convert that. And in the meantime, I'll let Achraf introduce himself real quick, and then also talk about the platform, the Kubernetes cluster, how it scales, how it's secure, and so on. And I'll show you the JSON in the background.
Thanks, Arno. Hey, everyone. So as Arno mentioned, we're not only innovating on the AI front, we are also innovating on our enterprise features. Of course, as a data platform, there's a need for collaboration. So users would need to share data between themselves. We do support that in h2oGPTe. You can share collections, you can share documents by way of sharing collections. You can also make a collection public, so everyone who has access, authenticated access to the system can use as a RAG context. And every microservice we build it in a way that it can work on-prem. Everything's Kubernetized, it's cloud agnostic, it can run on the major clouds. We also do auto-scaling, so we use tools like Keda to trigger on certain internal metrics to decide whether we need to auto-scale up or down depending on the workload. Now all that also need some role-based controls. We have ways by which admin users can set up different roles and have subset of users having different set of permissions. So all that is also managed in h2oGPTe. And also one other important topic is security. We take that very seriously, so we're very on top of vulnerabilities. We have no highs, no criticals. It's always an ongoing effort to get everything cleaned up. We're pretty much better than, I would say, any vanilla Docker image that you would pull for any of our sub-services. And as Arno's showing, we are exposing everything that can be done from the user interface in a Python client that you can just pip install from PyPy, JavaScript clients, but also through a REST API that's self-documented, and we've bundled in a few connectors there, Golang, Java, and Python. I think the other thing we wanted to show was the device pairing. If you can go to that link. So we've built a mobile phone app and a macOS app, and you can, by scanning this QR code, it authenticates and it does handshakes that allows the application to be paired with h2oGPTe, so you can directly from your phone just take pictures or import documents, ask questions, and you'd get the results back. With that, I'll defer back to Arno.
Thanks, Achraf. And the last thing is there is a repository on GitHub called Enterprise h2oGPTe, and that shows you the RAG benchmarks and also how to reproduce the results. And we can show you that you get like 96% accuracy on RAG. And these are complicated questions, right? These are questions of screenshots of tables and charts and diagrams and handwritten documents. What's going on, what's wrong with this hand drawing from a student in physics. It will correct the math and stuff. So it's pretty interesting stuff, and you can contact us later. And there's going to be also a hands-on session during lunch break. So thanks a lot, and the next speakers are up.